Welcome everyone. This video is for grade 10, 11 and 12, and today we're looking at maps, plans and other representations. These are the topics that we will cover in this video: grid reference, general direction, symbols of houses or buildings, maps and scales, and for grade 12s we will look at how to work out a scale. Question 1. You're being asked to find the grid reference of certain locations at the Licking Park Zoo, starting with lions. What is the grid reference of lions? Okay, lions are over there, and the corresponding letter is C, and the corresponding number is 3. So we'll say that lions are at, the location of lions is at C3. Next question, the grid reference of penguins. Alright, penguins are over there. The corresponding letter is D, and the corresponding number is 2. So the grid reference of penguins is D2. Question 2 is the general direction. So in the exams you might also be asked to find a general direction, and of course these questions are looking for you to give the general direction by looking at your compass. Alright, so we use the compass to find the general direction. Alright, so number 1, we have to find the general direction of Great Apes to Flower Garden. Alright, where are is the Great Apes? Great Apes are over there, and Flower Garden is over there. So what is the general direction? In which way are we going? We're going that way. From Great Apes to Flower Garden. And of course, if we consider our campus, the compass, we have north there, we've got east there, we've got south over here, and then we've got west. So if you're going that way, you're going in the northwest direction. Okay, so northwest. Second question, find the general direction of lions from penguins. Now this is very important. From penguins means you start at the penguins because you're coming from penguins. So where are penguins? Penguins here. We're coming from penguins. So the general direction of lions from penguins to lions. So that general direction is going that way. So that would be northeast, in the northeastern direction. Question 3 looks at different symbols that you will find. It can be found in house or building plans. Let's look at these symbols one by one, starting with the solid wall. Right, we've got a wall there and it's bold, which tells us that the wall is solid and goes up to the ceiling. That's also a wall, but we could see that it is plain, indicating that the wall does not reach the ceiling. Right, we've got a wall again with a window in between. We could see that line, it represents a window, so it's a wall with the window. And here we've got a door, and of course we know it's a door because we could see the opening, the door opens. And over here we've got the sliding door. We could see the two sides of the sliding door. The bath is obvious, so is the toilet, and then the shower. This part is the sink, and of course you've got double, two of those sinks, so that's a double kitchen sink. And then a single bed, followed by a single armchair. All right. Now we move on to question 4, maps and scales. All right. We have 2 types of scales, which is your ratio scale. This is your ratio scale where you write a number is to another number. Ratio scale, sometimes referred to as the number scale. And the second type of scale that we use is a bar scale. All right, how do we then explain the meaning of those scales? How would you explain the meaning of a ratio scale? All right, the number on the left-hand side of the ratio is the map distance, and the number on the right-hand side of your scale represents the real distance. So if we are explaining the meaning of the scale, we would say that 1 unit, and that's the left-hand side, so 1 unit on the map represents or is equal to, in this case, 50 million units in reality. And that would be the meaning of that ratio scale. Explaining the bar scale is slightly complicated because now you need to measure the bar before you can explain. I'll repeat, for a bar scale you need to measure first. We just need to measure from 0 to 1, just 1 bar, to see how long that is. So if we measure the 1 bar from 0 to 1, we'll find that it's actually just trying to be accurate, from 0 to 1, it's 50. Can you see that? And of course my ruler here is doing measurements in millimeters. So 1 kilometer, or rather, is represented by 50 millimeters on the map. So that's how you would explain the scale. You would say, okay, we've measured this. 50 millimeters on the map represent or is equal to 1 kilometer in reality. All right, the only trick with the bar scale, I repeat, is you have to measure first. So you'll have 50 millimeters on the map representing 1 kilometer in reality. All right, let's do a calculation. You are asked to use a scale to find the actual distance. How can we use the scale to find the actual distance from Stellenbosch to George? Okay, Stellenbosch is over here and George is over there. All right, so before we can use our scale to find the distance, we first need to measure. Of course, you could do this using a ruler. So we measure the distance from Stellenbosch to George. All right. It's about 385, more or less, millimeters. So then you would take the 385 millimeters and you would multiply it by the 50,000 from the scale. Multiply that by 50,000. So let's just do that. 385 multiplied by 50,000 equals to 1,925,000 millimeters. Remember, we measured in millimeters. You could also measure in centimeters. Doesn't really matter because at the end we are going to convert this distance anyway. So that is our real distance, but this distance is now in millimeters. And of course, we know that distance from one place to another must be written in kilometers. All right, so we need to convert that distance to kilometers. All right, so that is our distance converter. And of course, if you're struggling with conversions, there is a video on conversion, so please look out for that video. Okay, so if we want to convert millimeters to kilometers, we would divide by 10 to get to centimeters, and then we divide by 100 to get to meters, and then finally we divide by 1,000 to get to kilometers. So if we take that distance and we divide by 10, and then we divide by 100, and then we divide by 1,000, we find that our distance is 19,25 kilometers. Of course, this is just an example. That wouldn't be the real distance from Stellenbosch to George, just an example. So let's repeat. If you are given a ratio scale and you are expected to convert to use that scale to find the real distance, you first need to take your ruler, measure from one place to another, whichever places that they're expecting you to find, and then whatever measurement you get, in this case we got 385, you would multiply that measurement by the scale that's been given, in this case 50,000, to get your real distance. And the final step would be to convert that distance to kilometers. All right, this is where we say goodbye to grade 10 and 11. The next part is for grade 12s only. Grade 12s are also expected to be able to work out the scale. All right, it's very, very easy. If we are given distances, here we're given that 3 centimeters on the map represents 60,000 kilometers in reality. And you are expected to find the scale for those distances. And then, of course, you must first write it out in ratio form. So you have 3 centimeters representing 60 kilometers. All right, so what you want to do next is you want to convert the kilometers to centimeters using your distance converter. All right, so you've got kilometers, meters, centimeters, millimeters. So that's 10, that's 100, and that's 1,000. All right, so if you're converting the 60 kilometers to centimeters, you're going forward. So, excuse me. So you would multiply first by 1,000 to get to meters. And then from meters, you multiply by 100 to get to centimeters. So you've got 3 centimeters is 2. So we always want to convert the units, the bigger unit, so which is always the unit on the right. So if we convert the 60 kilometers to centimeters, so we take 60 and then we multiply by 1,000. And then by 100, we get 6 million. All right, so now they are both in centimeters. And once we have both sides in centimeters, we may now simplify to get our ratio scale. We divide both sides by 3. It's the smaller unit. And on the left, we now have 1. And of course, 6 million divided by 3 will give us 2 million. So our scale would be 1:2 million. It's very easy to find the scale. Remember, the map distance must go on your left and the real distance goes to your right. And once you've put your distances, always convert the bigger unit, in this case it was kilometers, to the smaller unit. So convert kilometers to centimeters using your distance converter. And once you've converted and both sides have the same unit of measurement, you may simplify to get your ratio scale. Finally, the bar scale. Using the bar scale to find the ratio scale, also easy. But again, if you have a bar scale, then you have to measure. And it's much easier if we measure the entire length of the bar scale. So if we measure over here, the entire length, remember the bar scale starts there at 0 up until 10 kilometers. All right, so if we measure, we find 301. Okay, 300 to 301. All right, so we've measured the length of this bar scale and it's 300 millimeters. So now we can write it out in ratio form. Remember, the question's asking you to convert the bar scale to a ratio scale. So we've measured that entire length is equal to, from the beginning to the end there, that entire length is equal to 300 millimeters. So 300 millimeters is to 10 kilometers. All right, and remember what we said, we always want to convert the bigger distance, so the distance on the right. So now we want to convert that distance from, so when I look at our distance converter there on top, we want to convert the 10 kilometers to millimeters. Okay, let's do that quickly. All right, 200 kilometers, we've got 1,000. Over here, we've got meters and then centimeters. So to convert the kilometers to millimeters, we multiply by 1,000 and then by 100 and then by 10. All right, so let's just do that quickly. So we'll get a big number. If we take 10 multiplied by 1,000 to go to meters, and then multiplied by 100 to get to centimeters, and then multiplied by 10 to get to millimeters, it will give us 10 million. All right, so let's write it out. So we've got 300 millimeters represents 10 million. And of course, once we have both sides in millimeters, we can divide by 300 millimeters, both sides, to find our ratio scale. Of course, the left hand side will be 1. 300 divided by 300 is 1 millimeters, and cancel out. This side with the millimeters will cancel out also. And now 10 million divided by 300. So we already have 10 million on the screen. So we divide it by 300 and it comes to 33,333. Because we leave our ratio in to the nearest unit. Okay, that would be how you find your ratio scale. All right, thank you grade 12s. Please also remember to subscribe and like this video.